Download this code from codegive.com, link in the description below. Puzzle game, Graph Theory Challenge. Graph theory is a fascinating area of mathematics and computer science that deals with graphs, which are structures made up of vertices, nodes, and edges, connections. We can create a puzzle game based on graph traversal and manipulation. Game concept. In this game, players are tasked with solving various puzzles by navigating through graphs. Each puzzle will consist of a set of vertices and edges, and players must find paths or complete specific tasks, such as finding the shortest path between two nodes, checking if the graph is connected, finding cycles in the graph, coloring the graph with the minimum number of colors. Game mechanics. 1. Graph representation. The graph can be represented using an adjacency list or matrix. 2. User interaction. Players can input their starting and ending vertices. 3. Output. The game will display the solution to the puzzle, such as the path found or the number of colors needed. Code example. Let's implement a simple version of the game using Python, focusing on finding the shortest path using breadth first search, BFS. Step 1, Graph representation. We'll represent the graph using an adjacency list. Python. Class graph. Def __init__, self. Self.graph equals. Def add_edge, self, u, v. If u not in self.graph. Self.graph u equals. If v not in self.graph. Self.graph v equals. Self.graph u.append, v. Self.graph v.append, u, indirect graph. Step 2, BFS algorithm for shortest path. Now, let's implement the BFS algorithm to find the shortest path in the graph. Python. From collections import dic. Def BFS _shortest _path, graph, start, goal. Q equals dic, start, visited equals set. While Q. Current, path equals Q.popLeft. Visited.add, current. If current equals goal. Return path. For neighbor in graph.get, current. If neighbor not in visited. Q.append, neighbor, path plus neighbor. Return none if no path is found. Step 3, Game interaction. We can create a simple interface for players to interact with the game. Python. Def main. G equals graph. Adding edges to the graph. G.add_edge, A, B. G.add_edge, A, C. G.add_edge, B, D. G.add_edge, C, D. G.add_edge, D, E. Print, graph created. Print, G.graph. Start equals input, enter the starting vertex. Goal equals input, enter the goal vertex. Path equals BFS _shortest path, G, start, goal. If path. Print, F. The shortest path from start to goal is, --join, path. Else. Print, F. No path found from start to goal. If __name ___ equals __main __. Main. Step 4, Running the game. To run the game, simply execute the script. You'll be prompted to enter a starting and goal vertex. The program will then calculate and display the shortest path, if it exists, using BFS. Possible extensions. Graph coloring. implement a function to color the graph using the minimum number of colors. Cycle detection, add functionality to check if the graph contains cycles. User interface, create a graphical user interface, GUI, using libraries like tkinter or Pygamy for a more interactive experience. Level design, create different levels of puzzles with increasing complexity. Conclusion. This tutorial provides a basic framework for creating a puzzle game focused on graph theory. You can extend the game further by adding more functionalities and features, making it both educational and fun.